Now over to this new problem. Mars has two moons, Phobos and Deimos. Now part 1 of this problem. Now Phobos is a period of 7 hours and 39 minutes and orbital radius is 9.4 into 10 raised to power 3 kilometer. Calculate mass of Mars. Correct. So we have been given the time period and orbital radius, and we have to calculate the mass of Mars. That is first part. So let us do it, and second part we will start when we complete the first part. So part 1 here, time period. So T is equal to 7 hours and 39 minutes. So that comes to 7 into 60. So that is 420 plus 39. That is equal to 459 minutes. So that is 459 into 60 seconds. Now we have to calculate the mass of Mars in kilograms, correct? And that is why we have to have SI units here. So I have converted time period into seconds. Now what is the relation that we are going to use? We are going to use the relation T square is proportional to R cube, correct? So now here T square is equal to 4 pi square upon Gm into R cube. Now what is my R? Orbital radius, second part of the data, that is 9.4 into 10 raised to 3 kilometer it is. So that is going to be equal to 9.4 into 10 raised to power 6 meter. Again SI unit. Now so I want mass of Mars, so I have to take this over here and that T square will go there, correct? So my mass of Mars is equal to 4 pi square upon G into T square, and that multiplied by R cube. So now that is equal to, now I am going to substitute. This is 4 pi multiplied by, what is my radius here? It is 9.4 into 10 raised to power 6 cube of that, divided by, my G is 6.67 into 10 raised to power minus 11 multiplied by T square. So my T is 459 into 60 square of that. So this is square, pi square this is, correct? So now here let us see the powers of 10. 10 raised to power 6 cube, so that would be 10 raised to power 18. 10 raised to power minus 11, and here this is now 459 into 60, correct? So that would be about how much? This would be let us say 450 into 6. 450 into 6 would be about 2700 and then square of that, correct? So this whole thing is, you are going to have about 10 raised to power 4 or minus 4 over here, and then finally when you get your answer here, it is going to be of the order of 10 raised to power 23. So now this whole thing that you can calculate using your calculators. Okay, now we will proceed with the part 2 of the problem. Now part 2. Assume that Earth and Mars, they move in circular orbits around the Sun, with Martian orbit being 1.52 times orbital radius of Earth. Now what does it mean? it means that the radius of orbit of Mars is 1.52 times radius of orbit of Earth. Correct. So we take now we know. Do we know the time period? What is the length of Martian years year in days? Now for Earth, the time period of rotation around Sun is 1 year, that is 365 days, and they want us to find the length of Martian year in days. Correct. So again we have to use this t square is proportional to r cube. Now this r I'll write small r here. Correct. Now suppose my time period of Mars, it is t1, radius of Martian orbit is r1. So similarly t2 square is proportional to r2 cube. This suffix 2 is for Earth, and then if I take ratio of these two, what happens? These two proportionality signs will go and I'll have equal to sign, because the constant of proportionality in both the cases is 4 pi square upon gm, which is constant. Correct. So now here, and that gm, in that m is mass of Sun. Correct. So it is anyway going to get cancelled. So now t1 upon t2 whole square, we want to find t2. Okay. So this is going to be r1 upon r2 cube. We have been given that Martian orbit is 1.52 times that of Earth. So it is 1.52 r1 upon r1, 1.52 times r2 upon r2 here, and cube of that, and that is going to be equal to t1 upon t2 square. Right. So now what? This r2 gets cancelled. So 1.52 cube is equal to t1 upon t2. So my t1 is going to be equal to t2 into, correct. So what I'm going to do, what I've done here, I have taken square root on both the sides. Correct. So it would be 1.52 raised to power 3 by 2, that multiplied by 365 days. So it's 1.52 raised to power 3 by 2 into 365 days. So that many days. This number you can calculate with your calculators, and that's how we do it. What we have done here is we have used Kepler's law. Okay, very simple. I have just taken t square proportional to r cube, and I just substituted. I took ratio and I got my answer. Thanks so much.